Have you ever wondered how we quantify the immense, invisible force of the wind, especially when we talk about turning it into electricity? It is a fascinating question that leads us directly to the fundamental physics of motion, allowing us to understand and harness this powerful natural resource. The kinetic energy of wind, which represents the energy of its motion, is primarily calculated using a foundational physics formula. This formula states that kinetic energy, often denoted as E sub k, equals 1/2 multiplied by the mass of the air, multiplied by its velocity squared. So, E sub k equals 0.5 times m times v squared. Now, to understand the why behind this formula in the context of wind power, we need to consider how mass is handled for a moving fluid like air. Unlike a solid object with a fixed mass, the mass in wind energy refers to the air flowing through a specific area over a period. This air mass is determined by the air's density, which is its mass per unit volume, multiplied by the volume of air passing through the turbine's swept area per second. Since the volume of air passing per second depends on the wind speed, the mass term effectively incorporates velocity, leading to the crucial cubic relationship for wind power. The formula for kinetic energy itself directly shows that doubling the wind speed quadruples the kinetic energy. To put this into practice, engineers use this kinetic energy formula and its derivative for power to estimate the potential energy that can be extracted from a given wind resource. First, you calculate the mass of the air flowing per second through the area swept by the wind turbine blades. This mass flow rate is the air density multiplied by the swept area and the wind velocity. Then, you plug this mass flow rate and the wind velocity into the kinetic energy formula to find the kinetic energy per second, which is essentially the power available in the wind. Remember, the actual electrical power generated will always be less due to aerodynamic, mechanical, and electrical losses, typically captured by a power coefficient. A key insider detail is the distinction between kinetic energy and kinetic power. While kinetic energy is proportional to velocity squared, the power available in the wind is proportional to velocity cubed. This happens because increasing wind speed not only increases the energy of each unit of air, but also increases the asterisk amount of air passing through the turbine per unit of time. This cubic relationship is why even small increases in wind speed lead to significant gains in available wind power, making accurate wind speed measurement absolutely critical for wind from site selection and turbine design. Ultimately, grasping the kinetic energy formula and its application to wind power provides a clear understanding of the fundamental principles driving wind energy conversion. It highlights that the speed of the wind is by far the most influential factor in determining how much energy, and therefore how much power, can theoretically be captured from this clean, renewable resource. This knowledge is essential for anyone looking to truly comprehend the engineering behind sustainable power generation.